Finally, let's look at part D. Y equals inverse sine x squared minus 1. The inner function is x squared minus 1. It's not a linear function, so we can't use a generalized formula to get the derivative. Therefore, we are going to apply the chain rule. Let u be the inner function x squared minus 1. The outer function is inverse sine u, and u must be between -1 and +1, and points are not included. To get the derivative of each function, du dx is equal to 2x, dy du. By using the first formula here, it is equal to 1 over root 1 minus u squared. By the chain rule, we will have dy dx equals dy du times du dx. Substitute the above derivatives in, we will have 1 over root 1 minus u squared times 2x. And it can be written as 2x over the root 1 minus. U will be replaced by x squared minus 1. For the brackets here, we can use the perfect square of difference formula to expand. A minus b all squared is equal to a squared minus 2ab plus b squared. Therefore, the denominator is 1 minus x to the power 4 minus 2x squared plus 1. Since by comparing with formula a is x squared and b is number 1. By expanding the brackets, the positive 1 becomes negative, and 1 minus 1 is 0. Therefore, we will have root negative x to the power 4 plus 2 squared. For these two terms, obviously, there is a common factor, x squared. Then we will factorize x squared times 2 minus x squared. For the product, we can separate them to obtain root x squared times root 2 minus x squared. For root x squared, it is equal to absolute of x. Then simplified further to obtain absolute of x times root 2 minus x squared. Since the numerator contains x and denominator contains absolute of x, we try to get rid of the absolute sign to simplify the result further. For absolute of x, based on definition, it is equal to x when x is greater than or equal to 0, and it is equal to negative x when x is negative. Therefore, we have to find the possible values of x for this question, since u is between -1 and +1. X squared minus 1 is between -1 and +1. Now we will focus on this inequality to find the possible values of x. We can add 1 to each part of the inequality, make x squared alone. Therefore, we will have x squared greater than 0, less than 2. There are many different ideas to solve this inequality. We will use the idea based on the function y equals x squared. The graph of the function is a parabola. It opens up and the vertex is the origin. Then we are going to illustrate the lower bound and the upper bound. For y equals 0, it's just the x-axis. For y equals 2, it is the horizontal line, y equals 2. Since the endpoints are not included, we are going to use the open circle to exclude the points. Therefore, for y between 0 and 2, the corresponding graphs are these two parts. Try to find the corresponding x values. We will need the coordinates of these 2 points. For the equation x squared equals 2. Also on the right part, we will have positive root 2. Left point, the corresponding x value is negative root 2. It tells us for this inequality, x should be between negative root 2 and two endpoints are not included, or x is between 0 and positive root 2. We record the possible values of x here. When x is between negative root 2 and 0, the absolute of x will become negative x. Then cancel out x. We will have negative sign in front and 2 over root 2 minus x squared. When x is between 0 and root 2, absolute of x is x. Similarly, cancel out x from top and bottom. We will have 2 over root 2 minus x squared. It's our final result. Looking back at the process, a key step is to determine the possible values of x using the inequality. And then consider the cases when x is negative and when x is positive to get the simplest form of the result. That's all for this section. Thank you very much for watching.